As machines become smarter in their interactions with humans, will they ever develop consciousness? And will artificial intelligence actually surpass human intelligence? While some machines have exceeded human ability in games like trivia
Now we come to Watson.
and chess, these AI systems were designed to master just a single skill. These programs use brute force computer processing power and specially tailored software to beat their human opponents. To achieve the holy grail of hyperintelligence, scientists must develop systems with flexible, human-like abilities to both learn and think. This form of smarts is called artificial general intelligence. I'm back in New York City on my own campus at Columbia University to meet with Dr. Hod Lipson. Hod's lab is developing creative robots that paint original artworks, self-assembling robots, and even robots that learn about their world without human assistance. But his ultimate goal is even more ambitious.
Can a machine think about itself? Can it have free will? I believe that, in fact, machines can be sentient, can be self-aware in ways that we can't.
As a neuroscientist, I know we've only scratched the surface of our scientific understanding of how consciousness works in humans. How could one possibly use computer code to put this transcendent feature into a robot?
Our hypothesis is actually very simple. It is that self-awareness is nothing but the ability to simulate oneself, to model oneself, to have a self-image.
The first step towards creating robotic consciousness is to teach the software to build an image of its physical, mechanical self inside its computer mind. We humans take consciousness like this for granted, even in simple moments, like understanding our own image reflected in a mirror. Humans start to develop awareness of their own emotions and thoughts around the age of 1. This helps babies understand their self-image in their minds, and it helps them to learn about their environment and their role in it.
When a robot learns what it is, it can use that self-image to plan new tasks.
In both humans and robots, awareness about the physical self is called proprioception. Neuroscientists sometimes call this self-awareness of our bodies a sixth sense.
We use the same test that a baby does in its crib. A baby moves around, flails around, moves its arm in ways that look random to us, but they're not random. And then it touches its nose, right? Now, if its brain predicts that it's going to feel something, and it actually feels that, that means that its self-image was correct. Same thing happens with a robot.
If proprioception can be developed to the same level as humans, this could lead to robotic consciousness. Hod's colleague, Rob Kwiatkowski, is the proud parent of a brand new baby robot that he built. And by interacting with its surroundings, it's in the process of developing its own internal self-image.
So what are these claws?
So these are actually feet. They're designed for walking on carpet, but as of now, it doesn't really walk. It's still kind of a baby. It needs to learn how the world works first.
What do you mean it's still kind of a baby? What is it doing?
Like a baby, it's sending completely random actions to each of these robot arms and really try to get an understanding of itself primarily.
It looks like a spider that doesn't know how to use its legs.
Yeah, I guess that's a pretty good way to put it, yeah. So it will really be learning by doing this babbling for somewhere on the order of a day to a week. It will process this data to create an informative model of itself. And from there, imagine how it would walk, and then execute that walking in the real world.
These are the first baby steps towards developing its self-image. And like a baby, it will eventually learn to walk. We know this because an earlier version of this robot, using the same technique, learned to walk after 100 hours. But walking won't, by default, lead to robotic consciousness. And that's why self-awareness is so crucial.
This is a robot which we've taken to calling a self-aware robot. It is self-aware pretty much in a literal sense that it is aware of itself, its locations in space, and its dynamics as to how it moves.
Okay, so it kind of understands its own movements and where it is in space. How does it do that?
By leveraging this technique, which has become popular in recent years, called deep learning.
Deep learning is a form of artificial intelligence that, like the human brain, learns through raw data, unsupervised and without structure. Deep learning gives machines the ability to experience and process reality, like us. Rob has devised an experiment to test what this robot knows about its world.
You could think of it as if you're looking at these red cotton balls. You have some idea in space as to where they are.
Right.
Now, if you were to close your eyes and try to pick them up and put them in this cup. So obviously it's not a trivial task.
No.
But it's not the most difficult task in the world because we have a good proprioception. We have this good model of yourself. You know where your arm is in space relative to other things that you see in space.
But for this robot, there's a catch.
So where are the cameras?
So there's no camera. It's
None
if you
whatsoever.
were to close your eyes, you know the locations at the start, and it's picking it up and placing it completely blind.
Furthermore, it was not given a map or any formal instructions. The robot simply has to feel its way through the task.
All right, let's see it.
Give it a shot.
First, the robot learned how to use its arm through trial and error, developing a sense of proprioception. By exploring its surroundings, it generated an internal representation of the world and its place in it. The robot is using only its internal image of the external world to maneuver its arm to pick up all 9 balls and place them in the cup. I'm not sure that's something I could do with my eyes closed.
Huh. It's really just based off of understanding where you are in space.
Yeah, that's right.
Creating AI robots that have an internal model of their world is an important step towards machine self-awareness.
Self-awareness is sort of a similar proprioceptive capability, but applied to mental thinking. So if they think about thinking, they think about what they are, because once you can do that, it means you can plan things into the future.
Once robots become self-aware, they will need advanced ways to communicate with humans. Keyboards and screens are inadequate for complex thoughts. Robots will need to learn to speak and have natural conversations, like a baby who listens to those around her and learns to talk. Laying the groundwork for this kind of human-machine interaction is pioneering scientist Barbara Gross of Harvard University. Her seminal work in what's called natural language processing directly led to the development of voice-activated artificial intelligence. You know, like Alexa or Siri.
Natural language processing actually predates artificial intelligence and started with machine translation efforts.
The ability for a computer system to carry on a spoken dialogue with a person has been a long-standing goal of artificial intelligence research from its inception.
And it turns out this is a challenge because when you speak, what you say really depends on the context in which you say it.
Another challenge is the meaning of words can change depending on how they are delivered.
So one example is the contrast between saying, "That's fabulous," and "That's fabulous." Also, when we have a conversation, we mark paragraphs at the beginning with a rise in intonation and a fall at the end. So there's a whole way the speech signal tells you something about the context and something about the intended meaning.
Barbara's early research led to methods for programming computers to understand the meaning of spoken language by using clues from a person's tone and context.
So let's flash forward. The speech systems are amazing now because there are lots of recordings of people speaking that they can build their systems on.
As a result, AI has gotten much better at understanding what people say. However, there is still room for improvement.
The systems that do exist are pretty much focused on very narrow tasks. Let's take Siri and Alexa as examples. They're mostly oriented around a single question or a single request. And they presume that anybody will stay within the range of behavior that the designers imagined.
So, researchers are turning to machine learning. By training AI with hours and hours of human conversation, they can learn to better understand the context of how humans converse. Future versions of this technology will allow us to have natural conversations with our computers.
One of the things that's amazing to me is that the fields have succeeded so well that there are devices out in the world that people use every day. I never dreamed that would be the case in my lifetime.